6th grade, Module 6, Lesson 12, problem set. Number 1, the amount of precipitation in each of the western states in the United States is given in the table as well as the dot plot. So we have the states, Washington, Oregon, all the way down to Hawaii, and how much precipitation or rain they get every year in inches. So how do the amounts vary across the states? So looking at the dot plot, we have anywhere from like 10 inches to all the way up here, that looks like about 64 inches. So they vary greatly depending on where you are. So let's say the spread is large. Anywhere from, let's see, who has the lowest? Who is that 10 or around there? Nevada has 9.5 inches. Nevada at 9.5 inches. To who has the largest? It was about right before 65, so maybe 63 7/10. Is that the biggest? Yes, and that is Hawaii at 63 7/10 inches. So very large spread there. B, find the median. What does the median tell you about the amount of precipitation? Okay, so let's find the median. What I'm going to do is I'm going to use the dot plot and just cross off starting at one end and narrow it down to the middle. So one on the left, one on the right, one on the left, one on the right, left, right, left, right, left, right, left, right. So it's going to be this one right here is the median. So a little bit bigger than 15. So since they're not all the same, we have 15 3/10 and 15 9/10, but it's the bigger one, the bigger 15. So let's go with Colorado at 15 9/10. Another way you could have done it is you would have taken all of these and ordered them from least to greatest and then crossed off, and then you would have been sure that it actually is Colorado. So that's another way to do it, since this one had a lot of decimals and it's kind of hard to read. So let's see. The median was Colorado at 15 9/10 inches. So what does that tell us? It tells us halves of the states have greater than 15 9/10 inches and half have less than 15 9/10 inches. C, do you think the mean or median would be a better description of the typical amount of precipitation? Explain your thinking. So we know that the median is right here, 15 9/10. Is the median. Okay, so the mean, what I'm noticing is there's a lot of 10s and 11s and 12s, 13, 14, 15s, but then we have these outliers out here, like maybe that's like 57 and 63, and this out here, which is really going to bring the spread this way a little bit. So I think the median would be more in here, or sorry, the mean is going to be greater because we have these numbers that are pulling the average up. And if you actually find the mean is, I was about right, the mean is 24 8/10 inches, which you can find. So the mean's actually right there. I was pretty close. So you can find it by adding them all up and then dividing by however many states there were. And when you do, you get 24 8/10 inches. So that kind of reflects these extreme values that you have up here, whereas the median shows more of what is average for the state. So what is happening most of the time and where they're mostly gathered around. So, I mean, it's up to you. I think the median gives a better description, but let's see. So the mean, 24 and 8/10 inches shows the extreme values, or takes into account the extreme values, while the median seems more typical at 15 and 9/10 inches. So you can decide which one's better. There's really no right or wrong answer as long as you can make a case for it. Number 2, identify the following as true or false. If a statement is false, give an example showing why. A, the median is always equal to one of the values in the data set. So this is false, because if you have an odd or an even data set, then there isn't always going to be a middle number. So for example, if you had like 1, 2, 3, 4, so let's just go ahead and call that false. So false, because if we had 1, 2, 3, and 4, the median's right here in the middle. It would be 2.5. That makes sense. So let's say even data set, even numbers of data don't have a middle number, and you have to find it. Let's just go with that. If you show this example, that makes sense. It's hard to kind of describe now that I started describing it. Okay, B, let's pick a different color. The median is halfway between the least and greatest values in the data set. So that is also false. It's not just halfway between, because if you have back to the one where the number of French fries per bag, it's not just the example of what's between the first and the last, the least and the greatest. It's just the one that happens to fall in the middle. So if we had a data set like, I'll think of something easier, 2, 2, 7, 9, 5, or sorry, 5 is not in order, 7, 9, 9. Here, the median is 7, right? Because that's what's in the middle. But 7 is not in the middle of 2 and 9. That would be, let's see, the difference is 7, so 3.5. That would be 5.5 would be in the middle. So that doesn't always work that way. Sometimes it works that way, but it's not always true. So let's say not always the difference between largest and smallest. Okay. C, at most, half of the values in the data set have values less than the median. So that is true. Because the median, you're finding the halfway point, and so that then half the values have less, half the values have more. D, in a data set with 25 different values, if you change the 2 smallest values in the data set to smaller values, the median will not be changed. So if you're changing the 2 smallest values to different values, the median's not going to be changed. So that also is true, because we're only looking at the median. So the first numbers aren't going to matter. It would change the mean, but it's not going to change the median. E, if you add 10 to every value in a data set, the median will not change. So now this is going to change things, because if you're adding 10 to everything, that's going to get different. So for example, if you had 1, 2, and 3, so 2 is the median here, and you change it to 11, add 10 to everything, 11, 12, 13, now the median is 12. So you can't just add to everything and expect it not to change. So let's say that's false. Number 3, make up a data set such that the following is true. The data set has 11 different values and the median is 5. So 11 different values, median is 5. So 5 needs to be in the middle. And then we need 5 numbers on either side. So it could be anything. We're going to go 1, 1, 2, 2, 5, and then we can put anything above 5 over here. We could put another 5. Oh, I missed. We need one more digit. I'm going to put another 1 in there. So we have 3 1s, 2 2s, a 5, a 5. Let's go with another 5, a 6, 7, and an 8. So is that 11 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. And the median is 5. There are lots of different answers for that. Just 5 needs to be in the middle. B, the data set has 10 values and the median is 25. So now we have 10 values, median is 25. So in the middle, I'm going to put 2 25s, and then we can put anything we want on the outside because the median is going to be right here. There is not going to be an exact median, but if we have 2 25s, then the middle of 25 and 25 is 25. So let's go 26, 27, 28, 29, 24, 23, 22, 21. So is that 10 values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, and the middle median is 25. And C, the data set has 7 values and the median is the same as the least value. So we could do, what I'm going to do is if this median is the same as the least value, we could just do 7 values that are all the same. So we could do 7 7 sevens. So 1, 2, 3, 4, 5, 6. So you could do something like that. Or if you don't want to do that, you could do 1, 1, 1, 1, as long as this fourth one is 1, and then you could do 5, 6, 7. So this is still the median, and it's 1, and it's the same as the least value. Or you could do everything the same, and it's still the same as the least value. Number 4, the dot plot shows the number of landline phones that a sample of people have in their home. How many people were in the sample? So let's count them up. We have 3 there. 1, 2, 3, 4, 5, 6 there. 1, 2, 3, 4, 5. 1, 2, 3, 4. 3 there. 2, 1, 1. So let's add all those together. 3 and 6 is 9. 9 plus 5 is 14. 18, 21, 23, 24, 25. So there were 25 people in the sample. Why do you think 3 people have no landline phones in their home? I mean, you might have a cell phone. I don't have a landline phone in my home. So they're just, maybe someone can't afford it. So cell phone, can't afford, or you really don't need one anymore as long as you have a cell phone. C, find the median number of phones for the people in the sample. Okay, so I'll cross them out in green. So I'm going to get one on the left, one on the right, one on the left, one on the right. And just keep working my way in. So my median is 2. Two phones per home. Number 3. The salaries of the Los Angeles Lakers for the 2012-2013 basketball season are given below. The salaries in the table are ordered from largest to smallest. So we have Kobe Bryant, who made $27-something million, and Darius Johnson-Odom, who made $203,000. Just looking at the data, what do you notice about the salaries? Well, I notice there's a very large spread. There's a very, very big difference between Kobe Bryant and pretty much everyone else. So let's say very large spread. B, find the median salary and explain what it tells you about salaries. So we're just going to work our way toward the middle. So I'm going to cross out Kobe, Dwight, Robert, Powell, Antoine, Steve, Darius, Meta, Devin, Steve, Earl, Jordan, Jody. So the middle median is Chris Duhon. At $3.5 million. So what does the median tells us? Half make more than 3.5 million, half make less. C, find the median of the lower half of the salaries and the median of the upper half of the salaries. So median of the lower half, median of the upper half. Okay, so here's the lower half here, or the upper half. I'm going to cross out Kobe, Jordan, Dwight, Steve, Powell, Steve. So the median of the upper half is Steve Nash at 8.7 million. And then the lower half is Darius Morris at 962,000. C, so upper half. Median was 8.7 million. Lower half was $962,195. D, find the width of each of the following intervals. What do you notice about the size of the interval width, and what does it tell you about the salaries? So the minimum salary to the median in the lower half. Oh, sorry, minimum salary to the median of the lower half. So the minimum salary here to the median of the lower half here. It wants to know the width, so I guess we'll subtract them. Let's try that. So 962,195 minus 203,371. Be $758,824 for I. Median of the lower half to the median of the whole data. So median of the lower half was this. Let's do this up here. To median of the whole thing. So 3,500,000 minus 962,195. It's a lot of borrowing. 10 minus 5 is 5, 9 minus 9 is 0, 8, 7, 3, I'll borrow again, 14 minus 9 is 5, and then we do. So $2,537,805. Let's do the third one. Median of the whole data set to the median of the upper half. So 8.7 million minus 3,500,000. 5.2 million and then median of the upper half to the highest salary. So last one. Upper half 8.7 to the highest, 27,849,149 minus 8,700,000. $15,149,149. Oh wait, 17 minus 8 is 19. Oop, good thing we checked our work. 19,149,149. Number 6, use the salary table from above to answer the following. If you were to find the mean salary, how do you think it would compare to the median? Explain your reasoning. So remember, the median was right here, 3.5 million. So, but if we were to find the mean, that's adding all of these up and dividing by however many there are. I think the mean is going to be a lot bigger than 3.5 million because all of these large salaries are really going to skew the number upwards because these are they're not big enough they're going to get drowned out by these huge salaries. So the mean is going to be a lot larger than the median. So I would say the mean will be larger. Because of all the huge salaries. B, which measure do you think would give a better picture of a typical salary for the Lakers, the mean or the median? Explain your thinking. So I think that the median gives a better look, 3.5 million, because you've got all of these people down here. Someone's only making 203,000 and someone up here is making 27 million. So I think 3.5 million is a better picture, the median, than the mean. But you can say the mean if you want, if you can give a good explanation for it. The median seems better. Because it is more typical of most salaries.